Hello, this is the demonstration of my big data assignment. The project is titled Kafka Order Processing System, Real-Time Streaming with Retry Logic and Dead Letter Queue. In this video, I will walk you through the architecture, implementation, the key features, and a live demonstration of the system running end-to-end. This system simulates real-time order processing using Apache Kafka. It includes a producer that sends Avro-encoded order messages, a consumer that processes them with retry logic, and a dead letter queue that captures permanently failed messages. Now, let's go through the key features of our Kafka order processing system. First, we use Apache Kafka for real-time message streaming. Kafka handles the flow of order messages between the producer and the consumer, ensuring fast, durable, and scalable communication. Next, all messages are serialized using Avro. This structured, compact binary format makes our message exchange efficient and ensures that every message adheres to the defined order schema. Retry mechanism. Retries transient failures up to 3 times with increasing delays. Dead letter queue captures permanently failed messages for inspection. Real-time analytics. Categories running averages overall and per product continuously. Offset management. Commits offsets only after successful processing to avoid duplicates. Dockerized setup. Runs Kafka and Zookeeper with a single command for easy portability.
Let's take a look at the project structure and the component overview.
This is the Avro schema that defines our message structure. It's a JSON file that specifies an order record with 3 fields. Order ID as a string for unique identification, product as a string for the item name, and price as a float for the cost. The schema is shared across producer, consumer, and DLQ consumer to ensure all components can serialize and deserialize messages consistently. Avro uses this schema to create compact binary encoding, making messages much smaller than JSON while still being type-safe. Next is the docker compose.yml file. This file sets up the Kafka environment with 2 services, Zookeeper, which coordinates the cluster, and the Kafka broker, which handles message streaming. This allows us to run a complete Kafka cluster locally with just one command. The producer generates and sends order messages to Kafka. It has 4 key functions. Load schema parses the Avro schema. Random order creates orders with unique IDs and random product prices. Encode Avro serializes them to binary format. And main sends messages to the orders topic. It accepts CLI arguments for message count and send interval, printing each order as it's sent for tracking. The consumer is the most complex component with multiple responsibilities. First, it consumes messages from the orders topic and decodes them using FastAvro's schemaless user. Second, it includes an aggregator class that maintains running averages, both overall average across all orders and per product averages using a dictionary. Third, it implements intelligent retry logic. When process rec fails, it retries up to 3 times with exponential backoff, waiting 0.5 seconds, then 1 second, then 1.5 seconds between attempts. Fourth, if all retries fail, the message is sent to the dead letter queue topic for later inspection. Fifth, it only commits Kafka offsets after successful processing, ensuring exactly once semantics. If the consumer crashes, it will reprocess uncommitted messages. The consumer also supports CLI flags for max messages and idle timeout, allowing it to exit gracefully after processing a specific number of messages or when idle, which is perfect for demonstrations. The DLQ Consumer is a monitoring and inspection tool for failed messages. It connects to the orders-DLQ topic and consumes messages that the main consumer couldn't process after all retries. For each message, it attempts to decode it using the same Avro schema. If decoding succeeds, it prints the decoded order as a dictionary so we can see the ivory, product, and price of the failed message. If decoding fails, for example, if the message is corrupted, it prints the raw bytes for debugging. This tool is essential for understanding what went wrong and deciding whether failed messages can be reprocessed or need manual intervention. First, let's start our Kafka cluster using Docker Compose. I'll run Docker Compose up in detached mode, which starts both Zookeeper and Kafka in the background. Let's verify the containers are running. As you can see, both Kafka and Zookeeper containers are up and running on their respective ports.
Here you can see the Kafka and Zookeeper containers running successfully. This step ensures the consumer reads all messages from the beginning. Now I will open 3 terminals: DLQ, Consumer Main Consumer Producer, DLQ, Consumer Terminal. This terminal will show messages that fail permanently. Consumer Terminal. This terminal processes orders with retry logic. Producer sends 100 new orders into Kafka. This completes the demonstration of my big data assignment. I showed Kafka message streaming, Avro serialization, retry logic, real-time aggregation, and the dead letter queue mechanism, all running inside Docker. Thank you for watching.